I'm Stefan Seyfried from B1 Systems in Germany. I'm an OpenSUSE community member known as Seife usually. And today I'm going to talk about crashing the kernel for fun and profit. And actually I'm cheating a little bit because crashing is easy. Everybody can crash the kernel. You just have to hit a sysrq-c, for example, and the kernel is crashed. So the more interesting part is actually hanging the kernel, but the title was not as catchy, so I stuck to the old one. So why would anybody want to hang the kernel? Do you have any idea on why this would be interesting? Nobody. Okay. So the reason why we actually did this was a colleague of mine was implementing some kind of a watchdog mechanism for virtual machines. So that's a feature that VMware has, that if the machine crashes, then it's automatically restarted, or if it hangs. And for a customer of us, they wanted the same feature but with Xen, and so he implemented this using Nagios and stuff, and automatically restarting and migrating the machine. And when he was ready and wanted to deploy this, he said, "Oh, how can I test this?" And we said, "Okay, we can easily crash it, but crashing it is actually a case that's very easy to find out, because there's no answer to a ping. And if you look on the hypervisor, actually the VM is gone, so it's not running anymore. So that's very easy to detect." So in reality, we're seeing much more interesting problems with VMs, because they might still respond to pings. You might still be able to log on to the machine, but you cannot execute any commands anymore, or stuff like that. Or maybe sometimes there's some NFS mounts are hanging or stuff. I've seen lots of different kinds of hangs in practice, and so I tried to simulate a little bit of that so that we can really test this supervisor and to check if what he implemented actually works. Another thing, it's actually interesting to do this, because I found quite some things about the kernel that I didn't know before. I'm not a kernel hacker by profession. I'm just I'm not worried of writing a kernel module, but I'm probably not very good at it. I'll later show you the code so you have something to laugh. It's actually pretty interesting stuff to learn, because if you find out how to trigger such a hang, you basically might also have found a way to look. If you encounter a similar hang in a real life application later, it might be the same problem. Not always, but you get to know. You start to look at things that you wouldn't have before. So that was the interesting part for me. This is why not just hit sysrq-c. It's too easy. That's too obvious. The machine simply is away. It doesn't work anymore. It's like pulling the power plug. That's easy to detect. Yeah, there are different kinds of system hangs. For example, as the ping works. SSHD does maybe still accept the connection, or even put the banner out there, but you cannot authenticate anymore or log in. Sometimes I have seen something like this 2 weeks ago, where a machine actually, there were multiple persons were logged onto the machine, all had their shells open, and some of them were still able to execute commands, and others, if they tried to execute a command, it was just hanging. And we did actually not get around to find out what the real problem was, because the machine needed to go back into production, so we had to reboot the VM. But this was something we said, okay, this would be interesting to find out. Probably some lock somewhere was not released, and maybe a few of the virtual CPUs were blocked, so only on 5 or 6 of them still processes were running, and on the others they were waiting for some resource, stuff like that. Quite often, something I really see in the wild is that sometimes if a machine has some such problems, I mean, those problems are always bugs. Those are kernel bugs. They should not happen, but they do. Sometimes often it's that it looks like it's proc file system related. So the machine works fine, but as soon as you do some PS or some top or something like that, this particular shell where you started the PS or the top hangs, and you cannot interrupt it anymore. So how to simulate such stuff? I decided, or I thought the best way would be to write a small kernel module that grabs some of these logs and then exits and doesn't release them anymore. So that's easy. Write the module, grab the log in the init module function, and be done. Unfortunately, it's not that easy because all the stuff that's interesting is actually not available to modules, because most often, it's core kernel data structures that those logs are protecting, and the modules don't need access to those kernel data structures. So they are not exported symbols, and so you cannot access them. Some of them are not easy to find, and I actually also did not yet implement stuff that needs them, because it would be interesting to only break some of the processes. There are logs in the for some process context specific stuff in the task list, and it would be interesting to break them in order to bring the machine down or to make it hang. But unfortunately, that's not that easy, because that's not a global symbol that you can resolve, and you have the log, but you have to find the task list and walk the task list and find out the task that you want to destroy or to break, and that's actually beyond my scope as a kernel hacker. So one thing I found out pretty early when I tried is that the kernel is apparently designed not to be broken so easily, because all this data was not available readily for manipulation, so I had to find some tricks. So I remembered there is a thing that's called system.map, where you have all the addresses of all the symbols in the kernel. So you can find a nice log that you want to grab, pull the hex number of the address out of the system map, put that into your code, and then cast the pointer to the correct spin log type or whatever it is, lock the spin log, and this works. Unfortunately, the system map, of course, changes with every kernel version, kernel rebuild. So it's really, you need to rebuild a kernel for every you need to rebuild your module for every kernel you try this on, which is a little bit annoying. But fortunately, there's a nice function called kallthings lookup name, which allows, if the kernel is configured with config kallthems enabled, which the OpenSUSE kernel fortunately is. This allows you to look up the address of a kernel symbol, and this again makes it rather easy to find out almost any symbol in the kernel, and then this is pretty easy. I can show you a little bit of the actual code where it's doing exactly this. So the kernel hackers now better look away. And on the upper, I'm defining, for example, the RW log T. That's a read-write log for the task list. And in the kernel, the symbol is actually not my task list, but it's a task list log. But I use private names to make sure that it's not the global symbol I'm directly accessing. And so I'm simply casting the address, and later down the log is actually taken with a simple read log here. And this, I'm not 100% sure. I think the task list log that does not hang the kernel immediately, but it hangs as soon as a task exits or gets created. What I was actually trying to break was fork, but it was not that easy. Just breaking fork, usually something else always breaks with it. So that was the try here. So this is actually really not that hard to do. What is really hard is finding a good log that does not hang the kernel hard, but still allows some stuff to work. And those, unfortunately, are usually not those global locks that you can easily find via the k-allsims lookup. But what you would need to do here would be what would be nice would if we had a way, if I had a way to for example, walk the list of block devices and kill a block device, or hang a task, or do the dynamic stuff. That's not implemented yet. But maybe, I mean, I've asked some of the guys who I know who are working in this area. I already asked them today. Maybe there are some interesting logs to look at. Any suggestions? Or it just I'm not going to tell him because he's going to break my kernel. Also, so this it's actually pretty easy. I also find a good one, which is the proc subdir log, which protects the subdirectories in the proc directory, which does not make the kernel hang hard, but it does not allow any process to be started again, because every process creation and destruction is changing the proc file system, and as this is blocking, basically the machine is quite dead. So what would be nice to have now for this module would be if I had more some of the softer hang methods that do not kill the machine immediately, but still allow a little bit more than a simple ping to still work. Those will be harder to implement because I will need to implement a method, or actually find out if there's one in the kernel. But I doubt that's available to modules to walk the task list and stuff. So I think that's usually not really something you want to do want something to do from a module. So it's probably not available readily. So one thing that actually Dirk Müller, I'm not sure if he's here, actually asked me today, well, why didn't you just use systemtap? So you all know systemtap. Anybody know systemtap here? Yeah, okay. For those that don't know it, systemtap is an instrumentation framework where you dynamically generate kernel code, a module basically from some kind of a script language, more or less, where you can probe kernel functions and inject code. It also has a guru mode where you can insert plain C code, and you can change the kernel also from code running inside systemtap. You can change kernel variables. Nice example a colleague of mine always shows is, if he demonstrates systemtap, is how to reset the taint flag. That's actually because loading a systemtap module taints the kernel, because it's at least on a supported distribution, on a SLAS distribution, it taints the kernel because it's not supported, of course, and so you can reset the taint flag from the systemtap code. So, but you shouldn't do that. For the supporters' mental health. Systemtap is actually very powerful, but it's also has some safeguards, so it's not that easy to break the kernel from within systemtap, because it has some checks to actually make sure that you don't kill the kernel with your systemtap module. Another problem is that to use systemtap you need the debug info installed for the kernel, and I mean, I've seen discussions on the factory mailing list where the debug kernel debug info was actually super thought it was 4 terabyte big or something like that, which was probably an overflow calculation error in Zipper. But it's easily something like 1.5 or 2 gigabytes of disk space, which you need for the debug info to be able to compile these systemtap modules. And the debug info, of course, must be matching to the kernel you're running. So if you're trying this on a few machines with different set of kernels, that's quite some work to do. The next thing is, at least for me, I know what systemtap is, but I'm not really familiar about how to use it. So for me, it was easier to write a small kernel module because that's, well, as you have seen in the code, it's not much more than a hello world. The most advanced thing I'm doing there is the casting of the pointer or the k-allsims lookup name. So it might depend on the viewpoint, but writing a kernel module is actually easier than using systemtap for that. So where is the code? I'll show it again, and I've also put it onto GitHub. Actually, when I started this and when I thought about giving a short presentation about the topic, I was actually still thinking of, well, maybe that would be something that would be interesting for the upstream kernel, because there is, for example, something similar, the crasher module from, I think it's from Chris Mason, that's crash.ko, which you can insert and crash the kernel in various ways. It can call direct, call panic. It can cause an oops by different ways, dereference, a null pointer, and stuff like that. And I thought, well, maybe we can not only have a crash module, but also a hang module or something like that. But the more I was trying to get this to work somehow, and the more I was seeing what dirty hacks are needed, because I mean the k-allsims lookup hack is, I mean it's funny, but it's not really nice. So the more I was thinking about it, I'm pretty sure that stuff like that will never go upstream. So anyway, it might be useful for somebody, and so I've put it up on GitHub. And yeah, I can also do a short presentation, but there's actually not much to see. I mean, I will not do this on my laptop because then I can't finish my presentation because it will hang. But I've prepared a little bit. I have a virtual machine on this box, which I'm now logged in from here. And now I need to find out the IP address. So with the correct syntax, it will actually even work. So, for example, now it is still pinging, and this module, it's really trivial. I mean, you can give the method of how you want to hang the kernel as a kernel parameter. So today I saw a different code from Jan Engelhardt, who actually he created a device. If you open it, then it crashed the kernel. So something like that could be done here too, but it doesn't really matter. So you via the kernel parameter, the module parameter, you specify the method of how to kill the kernel. I mean, the easiest one actually, this was the first one I tried, was simply taking a spin lock twice, which is an instant deadlock in the module init path, and even with multiple processors, this basically means an instant kernel hang. There is no ping, nothing anymore, which is okay. I mean, the machine is dead, but it's not that useful because it's too dead. Actually, it's almost as good as switched off. So then it's actually, you can see a little bit of the evolution of the code. The next thing I tried, I said, okay, I'll try it not locking it directly in the module init function, but from a timer. So let's wait a second and then lock the spin lock. So in the timer function, I took this actually, I think the same lock, and well, then after 2 seconds it locked up hard, because with spin lock IRQ saves, IRQs are turned off if I understand correctly, and so it was not much better. Actually, the best one was the proc subtier lock down here, and this is the symbol is proc subtier lock, and this one is actually allowing the machine to survive a little bit. It's actually, if there are still running processes, they are continuing to run. So we'll test it here with screen, so I can create a few more. So we can see it still runs, and here build the module. So I have it sleep for 3 seconds so that I can switch over. But it actually, I hope it won't hang it hard. Well, you never know. So we'll see when it loads. Actually, the kernel instantly detects there's something wrong because the module init code apparently notices that there's some problem with the lock. But well, okay. I mean, it's designed to be that way. Other processes are still running, so the VM stat is still running, and top is also. It's not. Something happened. Okay. Sooner or later, the kernel complains that there's a soft lockup on the CPU because this CPU is now doing nothing else than. So it's getting more and more broken, but it's still. I mean, ping still works. So if you really have a really stupid test to check if the machine is running, the ping would still return. So we can also try to if SSH is still doing something. I don't think so. Or even just try it with telnet to port 22, so we see if the banner is still. So that's actually not. Normally that would be the open SSH banner, but there is nothing there anymore. So slightly more sophisticated Nagios test should now detect that there's something wrong, and kill the machine. So that's. But here, for example, this shell is still perfectly fine. So it might be that you have something that's actually actively reporting that the VM is still working, some kind of a heartbeat daemon or something like that. This would still work. So at least it's for testing of such a monitoring framework, it's a little bit better than simply pulling the plug. And yeah, that's basically. I mean, the other methods are worse from a perspective that they all basically hang up all hang the machine hard or the VM hard. So, I mean, what's to do there? I mean, first thing would be check if there are more interesting logs. I mean, what I basically did was I did grep for log and mutex in system.map, and then I got a list of candidates on what to try. Then I did grab the kernel source for those candidates and check what they are doing. And I mean, if it's only a log that's used in some obscure driver, in some obscure hardware driver or stuff like that, then it's probably not that useful to try to generally hang up a machine. And well, the ones that I found, I did implement, and basically. What's here now was enough for the job to get done. I'll try to in the future to get a little bit more in it as time permits. Today I actually had an interesting conversation with Dirk Müller, who told me he was fighting a bug on his factory machine when building packages failed sometimes and hung the machine, and that's actually interesting because you can also hang such a machine from user space without any kernel module at all. If you have a recent enough distribution, you can simply we can actually show it. I just need to reset the VM. So this very good because what he found out, what the problem of the bug was, that some packages during build we're doing XFS freeze, and he isn't even using XFS on his laptop or on his machine, and he was wondering why it was doing anything. And recently more file systems have grown the capability of being frozen, which is useful for snapshotting, for example. And so one of those file systems is ext4, which he was actually using. And the XFS freeze formerly used a private I/O controller to XFS, but now there's simply a generic I/O controller that could work on all file systems, and it actually does. So if you run XFS freeze on your root file system, the machine is pretty much dead pretty soon as something wants to write, and which is actually a very, very nice thing. I can show you if it's up again. Put it up. Because this one actually makes SSHD still answer with the banner and stuff, but you cannot log in anymore. So that was what I was thinking about. Was funny about it. So you not always need a kernel module. Sometimes. So right now, nothing happened. It still works. And probably stuff like a new shell also still works because that's already in the cache. Ping works. Telnet works, and or SSH works. It still answers with the banner, and it might actually be that SSH doesn't work anymore because it needs to read something from the disk, and now and it can't, so it's hanging. And anything that needs to access the disk now, dmask was apparently already in the cache, is now hanging, and you don't get any messages. So I'm not sure. I need something that's not in cache. Trying to tab complete /var. Too bad. Doesn't work. But I still can create a new shell. So that's actually an interesting hang. So that's, and you don't need a kernel module for that. So that's what I learned today. that you can do it easy, and that there are interesting ways to make systems hang. So that's for it. Any questions or hints on how? I'm still looking for good logs to take. Do you have a microphone? Or do we need one? Yeah, just I repeat it. Okay, the question is basically, why is this XFS freeze command available at all? Because what is the point of freezing the file system, not taking a snapshot and unfreezing it immediately? And the answer is, I don't know. So, I mean, I just learned today that this is actually a way to hang the machine, and also not it's what was surprising also for Dirk was that it was actually there's no XFS file system involved. So because the name is now misleading, and why there is a separate, that's actually, maybe some kernel hackers can tell you why it's implemented this way. Probably it's just one of those things where you say, okay, you really shouldn't use it, but, well, you can. Yeah. One more? I'm sorry? Okay, the question is how you can investigate such lookups, how you can find out if your computer is locking up randomly, how you can find out what's the problem. Basically, that's very hard. The thing that probably works best is to configure crash dumps and do a crash dump on that machine, because then you have all the whole state of the memory written to the disk, and you can investigate that there. But for random lookups, sometimes, I mean, the problem with such logs actually is that you would need to know who did forget to release the log, and that's even with the crash dump not easy to see. One example is, for a crash dump wouldn't even trigger because the kernel didn't crash, so you need a way to manually trigger the crash dump, which, depending on the log, you could still do with a sysrequest key. If it's just if interrupts are still on and input is processed, you could do it with the sysrequest key, or if it's on a basically, but only server hardware basically has this. If you have an NMI button, you can trigger an NMI and have this crash the machine. But stuff like this is very hard to debug, and especially locking problems. I mean, I've seen this in the wild, mostly with VMs, which are easy to dump because you can simply tell the hypervisor do a crash dump without crashing the machine, basically. And often support was not able to find out what the problem was because you don't know. I mean, basically, such a lock, if it's only accessed once an hour for some task, it can be an hour ago that this was forgotten to unlock, and it's hard to find out. So, no. What was interesting for me was actually looking at the different locks that are there, and so I think, well, if you actually know how to exactly simulate the problem, it might be interesting to, if you see the real problem at the same, it might be at the same code. Not of course it's not sure, but you get an idea. So yeah. Okay, the question is, of course, there's a educational point of view, educational benefit for hanging the kernel. What is the practical benefit of it? Well, the practical benefit for me or for my colleague was that we were actually testing the system's monitoring software, and we needed to somehow do a realistic hang of a VM to make sure that the supervisor that needs to detect if the machine is down and bring it back up again is actually working. So it's probably the same as with the Chris Mason's crash module. I mean, who needs a module that crashes the kernel? Yeah, and what for testing crash dumps or? Yeah, okay, and basically it's the same for that. So it's the same class. It's basically purely a debugging thing. So it's not. I wouldn't. For example, I mean no matter how bad the code is, but for example, if you just load the module without any parameter, it will simply do nothing because, if somebody loads this module without having read the documentation, I don't want to crash it or to hang his machine without at least noticing him. And the crash module does the same. You also need to specify which module with which method of crashing you want. So that's the same. So. Yeah, more questions? Everybody happy? So have fun at the party or whatever. Oh, sorry. Actually, I was thinking about the question is if I did consider hangups that are not caused by logs, and well, I couldn't find one. Should I phrase it? I did think about different ways to hang up the kernel, but actually, from those what I have seen in real life on hanging machines, well, I was of course guessing, but it was always looking like it was locking related. So that was actually was not. I thought about trying to inject stuff like hardware faults or break a device driver or stuff like that, but it's actually nothing that we rather see in real life. So I had no idea really. I mean, do you have something specific in mind? Hmm? Hmm. Yeah. Yes. Yeah. So yeah, the things Micha was thinking about were, for example, running out of resources with regards to open file handles and stuff, running into such limitations, or real-time processes that are not letting the others run. Actually, I was not thinking about real-time processes, and I was thinking about stuff like file handles, but we did actually test that by simply setting the U limits to unreasonably low limits, and then checked if the supervisor did catch that. So, well, there was no need to put this into the module. We could simply do this in user space. And actually, I mean, as I learned today with the XFS free stuff, this was the most effective. The system-wide limit, yes. Actually, I was just this week I was running into something similar, and this was too many directories in temp. And so I'm not sure which process. Something wanted to create a directory in temp, and the error message was too many links. And well, if you think about it, it's okay, because every directory needs a hard link to the upper directory and stuff. So yeah, it would actually be interesting to exhaust some of those resources. I didn't really think of this, so that's an interesting thing for. Yeah. Yes. Yeah. I mean, actually, what I was trying was not very successful, but what I was trying to emulate with this module was actually stuff I had seen in real life scenarios. I mean, once you need a hanging system, you don't find one. So, as always, so if you don't need them, you have lots of them. But once you would need one for testing your setup, there's nothing hanging. So. I tried to simulate stuff that we really had seen, and where until now I did fail, or it's not really a failure. I simply I didn't dare to tackle this walking the process list, finding out the list of NFS mounts and killing them somehow. This would be probably also interesting, and not just with a non-responding NFS issue, which is not that, but we really had seen that they were broken. It didn't respond. The network was there, but the NFS mount was broken, and this was one of those errors that disappeared before we could test it, and it was apparently disappeared after a NetApp update. So it was not really the Linux kernel's fault, but it still did hang our machine. So yeah, there are probably more interesting ways of hanging machines than what I have found out. But well, I had limited time, and it was good enough. Let's put it like that. Okay, more questions? So then, everybody have fun.